Hello, welcome. Today let's try to solve another Leetcode problem, 112, path sum. So we are giving the root of a binary tree, and we are also giving an integer target sum. We need to return true if the tree has a root to leaf path such that adding up all the values along the path equal to target sum. Yeah, so for example, let's find this path. So from the root to the leaf, 5, 4, 9 plus 11, 20, and plus 2, it is 22. So our target sum is 22, so we can return true. Yeah, so basically this is a DFS problem. We just need to use the DFS to find all the paths. While we are using the DFS, we can always check the node one by one from the root to the leaves. So if we find a path is equal to 22 to the target sum, so we're gonna return a true. Yeah, if we didn't find any of the paths equal to the target sum, we just needed to return a false. So from this problem, my intuition is the minimum or maximum binary tree. But yeah, it's exactly the same like minimum depth of binary tree. Because for the minimum depth of binary tree, we just need to check from the root to the leaves, to all the leaves. And this problem, we just need to add up all the values from the root to the leaves. If one of the value is the target sum, we can return true. Otherwise, we're gonna return a false. Now let me just prepare the structure of the minimum depth of binary tree. So I'm gonna use a DFS. So inside the DFS, let me design the algorithm. I'm gonna put a node inside. Yeah, let me just put a root because it's the same. I just needed to put a node inside. So this root is the root node from the beginning. And also let me prepare a number target. Yeah. So my target will start from 0. If I add up the target, add up all the value from the nodes to my target sum, I'm gonna return true, otherwise I'm gonna return false. So what I need to do, I need to call this DFS function to return my result. So it would be the root, and I'm gonna start from 0, because if from 0 I add up to the target sum, I'm gonna return a true. Yeah, let me put the root to be a node. Yeah, let's just make it more like a template code. Yeah, so now we can write the DFS. So let's first check the condition. So let's check the numbers of the node from 0 to 5,000. It means it can be, there's no root, for example, like this one. Yeah, so there's no root, we need to return a false. Yeah, because the target sum is 0, but we don't even have a root. We don't have a value of the root, so it's gonna be a false. So we need to first find our first condition is if not the root. So if not node, so we're gonna return a false. Now we need to check all the other conditions. So this is with no root. So what about if we have the root? Let's check this example. This example may be simpler than the first one, because first one we basically need to check all the other conditions. Yeah, but for solving the recursive problem or DFS problem, basically we just need to use a very simple example. If everything is okay, normally the algorithm should be okay. We don't need to check one by one, because this one, it takes time. Yeah, because we have to check one by one. So we don't need to use a very complicated example for writing DFS. We can use this example to write our DFS. So for the root like 1, 2, 3, or we can use another example maybe only with 1 and 2 without 3. Yeah. So basically, this kind of conditions include all the cases of the binary tree. Yeah. Now we have the node. So let's check. If there's no left child and no right child, if there's only a node, for example, if there's only a node 1 without 2 and 3, let's check what's gonna happen. So if not dot left and not dot right. So this means we already find a condition to the answer. Because there's no left side and no right side, we are sure this node should be the leaf. If we find a leaf node, we're gonna check if we find an answer or not. Yeah. So we just need to check if yeah, let's check the value. So the value should be the target. Yeah. So from the target, we need to plus the value from the root. Because from beginning, it is the root and 0 inside. And now, if not node, we're gonna return false. But there is a node 1. Yeah. Yeah, we just imagine there's no node 2 and 3 for this condition. If not left and not right. Yeah, so there's no left side and right side. What we're gonna do? We just need to plus the value from the root. So the target should plus not dot val. Yeah, so if it is equal to the target, if it is equal to the target sum, we're gonna return a true. Otherwise, we're gonna return a false, right? Yeah. So if it is equal to the target sum, we're gonna return a true. Otherwise, we're gonna return a false. So we can return this syntax directly. Yeah, just to save so many lines of code. Yeah, so we just need to return the target plus the not.val equal to the target sum or not. If it is equal, we're gonna return true. If it is not equal, we're gonna return a false. So this is the second condition. Now we are going to check all the other conditions. So what about if not dot left and not dot right? Yeah. So what about if we don't have the left node? We only have the right node. So what are we gonna do? We just need to recursively call the DFS. So we're gonna call the DFS. It's gonna be not dot right because there's no not dot left. So from the not dot right, we check the node, and then we're gonna check the value. So the value inside it's gonna be the target plus our root node. So it's gonna be not dot value. Yeah, because for example from here, we're gonna go to the right side. Yeah, from the beginning the value is target, it is 0. If we want to go to the right side, there's no left side, there's no this node 2. Yeah, if we want to go from 1 to 3, we go to the not dot right, but we need to plus the value of the root, it is 1. We need to plus this value. Yeah, similarly, we're gonna check another condition. Yeah, let's check another condition. If not dot right, but we have a node left. Yeah, but for like writing the recursive function for the boundary tree, so this is always symmetric. Yeah, as you can see like this. Now we just need to return the not dot left and the target plus the not dot val. So this should be the same. Yeah. Now let's just check the last condition. So yeah, the last condition is that we both have left and right. Yeah, because we've already checked if there's only left, there's only right, and there's no left and no right. So the last condition is there is both left and right. There's 2 and 3. Now let's just check this last condition. So what are we gonna do? We just need to return a DFS with the left or DFS with the right. Yeah, we just need to copy this code, and this is the right. Yeah, it's the same. Let's copy the right, and then let's just copy the left. Yeah, so this is how we analyze the DFS problem and the boundary tree problem. Yeah, I think this is the entire code. Let me make it just one line for the final return to make it more clear. Let me put it here. Yeah. Now let me just run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed, and it's 69% of all Python 3 submissions. And the time complexity is O(n). N is the number of the node. Yeah. Now let's try to check if we can optimize the code, because as you can see, there are so many conditions. There are 4 if conditions and a final return. Yeah. Do we need to have so many conditions to check? Because basically for me, I checked all the conditions. Yeah. And let's check the left and the right side. Yeah. So for this left side, if there's only left, we're gonna return a DFS. And here we have another DFS to return, and this is all condition to check the left, all condition to check the left and right. And also, if there's no left or no right, we just need if there's a not, it means if there's a from the left side, if there's no not, we're just gonna return a false. It means a false or a true. It can still be a true. It means we write some duplicate code. Yeah, but for this example, actually, this is exactly the recursive function did. Yeah, the 3 conditions, but we don't need to do that. So we can delete the left side and the right side. Why? Because this return the left and right with or already included all the situations from the only left and only right, because this is an or condition. It is not and. This is or. Yeah, we should know about it. And because if there's a no node, we're gonna return a false. So we can delete those 2 conditions. We don't need to check actually. Yeah, now let me just run it to check if it works. Yeah, let me put the target sum. Yeah, I deleted more characters. Now, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, even I deleted 2 lines of code, as you can see, it passed and it works perfectly because we didn't actually change anything else. We just delete some duplicate if conditions. Actually, we can put all the conditions inside the last line. So actually, this last line includes 3 conditions. If it only has left, or if it only has the right side, or if it both has left and right side, because it is a or condition. So this is why we can delete those 2 if conditions. Thank you for watching. See you next time.